So today we will start with the industrial enzymology. Why we s- want to study this industrial enzymology? Because enzymology, logy means it is study of certain science. So study of enzyme means study of enzymology. Now industrial enzymology, it means it must give certain product and it has a practical application in various ways, or that may be a industries of food base, that may be a industries of medical base, or in engineering, bioengineering used in that. So what are the advantages or disadvantages of biocatalyst in this technology? That we will study in the first topic, and second topics we will start with the stabilization of the enzyme which are used in the biotechnology. Same with how the generation of the enzyme systems can be utilized in the biotechnology, we will study in that. So very important topics we will study at end of this or in between of this unit 4, that is protein engineering. Protein engineering in relation to the enzymes. We will not isolate or any protein, but we are utilizing a protein as a substrate, and with the enzymes how this protein engineering can helpful in the industry. Then there are three terminology which are very useful for understanding the industrial enzymology. So first is chimeric of enzymes. Then, as I said or already discussed, that bifunctionality of enzymes. Then immobilization of the enzymes. This topic will cover in the creation, how to create the chimeric or bifunctional or immobilization of enzymes. We will study in the portfolio 4 or unit 4. Then semi-synthetic enzyme. Semi means it is half or it may be a synthetic one with the enzyme and how it can utilize in the various industrial process. So industrial biocatalyst you can use or production of semi-synthetic enzymes or application of that we will study it in this topic. Then lastly, at end of these, how these enzymology or technology or industrial enzymology information can useful in the enzyme engineering. So these topic we will cover in this. Now we will start with the biocatalyst. As you know that biocatalyst is name itself is an enzyme catalysis, or it is used or it is found in every biochemical reaction which are living organism. Okay, such as enzyme that will facilitate the certain chemical reactions in the various technological processes. This approach nowadays taken a very great significance, and many more peoples are interested in because of that having a certain traditional chemical processes, as well as there are a number of advantages too. Yes, there are certain limitations and challenges too. For biocatalyst it is a advantages and disadvantages where it is applied, it is the major things. Advantages and disadvantages of biocatalyst in the technology driven process. So first of all, as you know the characteristic of enzyme having a high specificity as well as selectivity too. So highly selective, specific for their reactions. They catalyze particular reaction with the great precision. Certain production of desired product that can be possible with the minimum utilization of their cells. And in contrast, this chemical catalytic process produce a mixture of product. This is the one of the major things we are observing in limitation also, or you can say advantages also there, because number of product can be formed with the mixture of that. So that requires when the unwanted minimal formation of unwanted byproduct, it is the major specificity or desired product to form. Whereas in case of traditional system, if you apply that enzymes, that will produce a mixture of product. When the mixture of product is produced, it requires a certain purification steps to desired advantages. Another things, enzyme will not work like as acid. Okay, it will not generally form like chemical reactions. It is very mild reactions. So typically occur under mild conditions as well as it requires a certain factors. As I said in the previous lecture, it is dependent on substrate, enzyme activity at specific temperature and pH. So it requires, if you are doing that enzyme production in industrial base, it also requires certain pressure also, or boiler requires a certain temperatures. So enzyme function can be operated at moderate temperature in general between 24 and 25 to 40 degrees centigrade. If it is goes beyond that 60-degree temperature, it will be nature. So at atmospheric temperature pressure 1 atm, it will works good. Sometimes also reducing certain energy consumption also. So it require minimum needs to for the costly equipments. So in contrast to traditional chemical process that requires a very sophisticated and instrument as well as utensils for the specific reaction, and that will lead to sometimes what will happen in traditional methods, you will find a certain side reaction too, because it is not channelizing. So desire to get the desired product, you need a sophisticated mild reaction with the enzyme. Another advantages of the enzymes, as I said, it gives a mild reaction. Not it is not a chemical process, or therefore it is very environmental friendly. So biocatalysts often significance or environmental benefits compared to the conventional chemical processes. Enzymes are derived naturally from source. We are utilizing natural source and are degraded, making them more sustainable and reducing the generation of toxic waste. Sometimes we are utilizing a toxic waste for the production of a specific product. For example, you are utilizing a molasses. The same enzymatic process you will generate alcohol. Okay. So additionally, biocatalyst reactions often utilize water as a solvent. Remember these words. Biocatalyst reaction often require water. For what? As a solvent instead of organic solvent. And that is not harmful. Water is not harmful. That can be harmful to the environment. What? Organic solvent. And water is not harmful. Therefore, it is environmental friendly. Then, chemo, regio, and stereo selectivity. Now, four words advantages of biocatalysts. They have this stereo selectivity enabling the products of complex molecules. For example, if you see the chemistry of that, it has a certain functional group or stereochemistry, whether it is alpha, beta, L, okay, D, the foam which are produced through this. These features is particularly valuable in case of pharmaceutical product or pharmaceutical production. So single enantiomer is crucial for drug efficiency and safety. So you can raise KMO, regio, stereoselectivities of the enzymes can or biocatalysts can useful for the pharmaceutical synthesis product. Okay. Now, one of the major things when you do any chemical reaction, it is utilized. You cannot utilize for further ones. In case of biocatalyst, it is a compatibility with the renewable or renewable feedstocks. It is well suited for a renewable feedstock such as biomass or agriculture waste. Enzyme catalyst can efficiently convert these material into a valuable products. As I today in India also, they have approved the 50% of ethanol mixed with the petroleum product. Okay. These align with the growing demand for sustainable and bio-based alternative to fossil resources. This is the one of the major example for biocatalyst or advantages. So you have to write these six major topics and you can write in your language also. Now disadvantages of biocatalyst. So there are disadvantages also there. Sometimes what will happen, we have limited resources as a substrate, or you can say limited substrate range is there. So enzyme, it works on specific substrate, therefore it requires specific substrate. Enzyme have a specific substrate requirement, and not all chemical compound can be radially be converted into converted by biocatalyst. So specific to specific substrate or raw materials. So some substrate may be toxic to the enzyme also, require complex activation steps, and limiting the scope of these biocatalytic reactions. So all substrate cannot be utilized if the substrate having a higher carbohydrate content, then it can be utilized for the various fermentation process. But before that, you require certain limited steps to conversion into a specific carbohydrates. This constraint open necessity for extensive screening and optimization process to identify the suitable enzyme for given reactions. So this is the one of the major topics you will find in the most of the journals. They are optimizing the enzyme process for extraction of certain oil, for extraction of certain compounds. Okay. Enzymatic pretreatments is applying for the milling also. So one of the limited substrate range is that you cannot mill uh, enzyme with the certain cereals, but you can utilize for that for specific product. So sensitivity to reactions condition is one of the major drawbacks you will find in the biocatalyst because it is sensitive to pH, temperature, and as I said, factor affecting enzyme activity or included in suboptimal condition is required, uh, can leads to the reduced enzyme activity. Or sometimes what will happen if the temperature increasing or the pH increasing, it will leads to the denaturation. So ultimately it is resulting in the decreasing in the reaction efficiency. So maintaining the optimal conditions throughout the process can be a challenging or additional required to control the major sensitivity to the reactions. Now, cost, one of the drawback, cost consideration. If you purchase the purified enzymes, it has a higher cost. Raw, it is a very low cost than the commercially available. So the production and purification enzyme can be very costly if you see the industrial point of view. Specialized and additional requirement is also required for. After that, production of that enzymes. or production of that mm, or purification process. One of the major things you require for the keeping or uh, maintaining that shelf life, certain requirement, storage condition is required. So these factors also contribute higher production of cost as compared to the traditional chemical methods. And it is also affected by environmental conditions because substrate is everywhere. Okay. So enzyme having a certain specificity, therefore it has a disadvantages. Now another scale up challenges and time consuming optimizations. It requires certain time also. Okay. So often require extensive, as I said previously, that optimized condition is required for nature's optimization or development of timeline. It also increases the cost and time consuming. Certain reactor designing is also required for careful consideration for economically viable large scale productions for the industrial point of view. If you see the scale up challenges for the biocatalyst reaction, that's successfully we are implemented in the laboratory scale, but it cannot be possible in the industrial way. So it requires a certain large number of substrate put into a boiler and then fermenter and then the reactors, depending upon your. So it is a very present significant challenges observed in the scale up challenges with the enzyme technology. So this is all about the very few and short about the advantages and disadvantages of biocatalyst for the technological intervention in industrial ways. Now, how the enzyme can play a role in the biotechnology. Biotechnology, as I said in the previously also, all biotechnology based on central dogma, and it requires a DNA ligations, DNA cleavage, and RNA ligation, DNA cleavage, and metallyl bindings, as well as third. RNA phosphorylation. Yes, this is the major things we were already studied with the which topic? DNA science or ribozymes. Okay. Or not central nucleic acid. Catalytic nucleic acid. So, as catalysts various biochemical reaction, this enzyme can be sensitive to environmental conditions, may cause, or sometimes it also loses the activity and stability of. Therefore, it is essential to develop a specific strategy for the stabilization and regeneration of the enzyme system in biotechnology. Two words are given here. One is stabilization, another is regeneration. Now, stabilization of enzyme systems can involve preventing or minimizing the loss of enzyme activity under the various conditions. What are that conditions? You can stabilize the enzymes. That can also be asked in the examination. Write the factors which can stabilize the enzyme. So in laboratory scales, you will find a temperature, pH, then substrate, then storage conditions, then other environmental also. Several approaches nowadays is being utilized for stabilization of enzymes. Certain food additives are also they are added for the enhancing the reactions or controlling the reaction also. So chemical modification is required. First, foremost important for the biotechnological, as I said, stabilization of enzymes. Chemical modifications can be performed to improve the enzyme stability. So for that, cross-linking agent can be used to create a active site or covalent binding between the amino acid residues that will increasing the enzyme resistance to denaturation. one of the ways for stabilizing an enzyme. Another chemistry that you can add introduction of new chemical groups such as PG, okay, polyethylene glycols. These P glycolations can shield your specific enzyme and it will release proteolytic or harsh condition or proteolytic degradation. Nowadays, chemical modification with the nanotechnological intervention is also applying for these chemical modification or stabilization also. Now the slow release enzymes or slow release compound are also available. Okay, with the coating also. So this coating can also be possible with enzymes. Okay. And bio product you can utilize for the various coating also. For example, pectin. Nowadays in immobilization. First, modification, chemical modification by any means, with biomeans. You can add certain chemical groups or chemicals to reduce that effect or reduce the denaturation. One of the major things. Another is immobilization. Immobilization refers to what? First of all, immobilization refers to the attachment of enzymes on solid support or matrix. Immobilization of enzyme means it refers to the attachment of enzymes on solid surface. This technique having a different numerous advantages, several advantages, including restabilization, reusable, enhanced stability, and it has very easy or ease of separations from the reaction product. So three words I have included. It has a several advantages. For what? Immobilization. With what? Solid support or matrices. This technique can having a it include a enhanced stability, reusability, and the ease of separation from the reaction product. Immobilization method include which are the methods which includes in the immobilization. One is adsorption, another is covalent binding, and third, you can say it with you can entrapment within the gel or polymers. Nowadays, microencapsulation is also utilized for within the microsphere or nanoparticles too. So this immobilization is related with what? Attachment with the attachment of enzyme with the solid particles. Okay, and you can utilize for various methods or chemistry like as adsorption or covalent bindings or entrapment with the gels also. Or you can also utilize polymers or microencapsulation process also. Now, third terms that you have to remember, very important for examination point, protein engineering. Protein engineering word itself, this technique, word itself, engineering thing with the long chain of polymer of amino acids. So where to put and where to remove. So can be employed to modify that enzyme at genetic level. What is the aiming of for that protein engineering? As I said previously, stabilizing and immobilization. So aiming to improve that stability, site-directed mutagenesis allows the introduction of specific amino acid substitution. When the site-directed amino acid introduction, or you can mutagenic use for that site-directed mutagenesis, that will introduce a new specific amino acid. as a substitute that enhance the stability of specific enzymes without compromising their activity, catalytic activity or catalytic. Uh, Now, direct evolution of techniques such as error from PCR or DNA shuffling can also be utilized to generate libraries of mutant enzyme with improved stability. That words you have to speak and write loudly. Direct.
Directed evolution techniques such as error-prone PCR or DNA shuffling can also be utilized to generate libraries of mutant enzymes with improved stability.
So for that techniques, error from PCR DNA shuffling. Okay, two words can utilize for what? To generate libraries of mutant enzyme with improved
Improved stability.
stability. This is